Hello again, 6 trig functions. Just like to put this up as like kind of an addition, because if you were confused before, this will only confuse you some more. But no, seriously speaking, it's just adding a little bit of elaboration so you can see the reciprocal functions in action, to see what really goes on here. Because sometimes taking in too much is too difficult, so it's a good complement to it. So the sine of theta is equal to the opposite over the adjacent side of the triangle. The cosine of theta is equal to, that's not true, it's the opposite over the hypotenuse of the triangle. Just thinking about that as I wrote it. The cosine of theta is equal to the adjacent over the hypotenuse, and the tangent of theta is equal to the opposite over the adjacent. What's really cool is this, that the opposite over the hypotenuse is the same thing as 1 over the cosecant of theta. And if you don't believe me, that's the same thing as 1 over cosecant is hypotenuse over opposite. And when I multiply opposite over hypotenuse, that's equal to opposite over hypotenuse. So sine of theta is opposite over hypotenuse. That's the same thing as 1 over the cosecant of theta. It's reciprocal function, not inverse, reciprocal. 1 over the cosecant is 1 over hypotenuse over opposite, but I can't have two denominators in the denominator, so I multiply by opposite over hypotenuse, bam, equals opposite over hypotenuse. So, something to think about there. Pretty cool. So, I'm going to go ahead and erase because I realized that maybe I was a little too ambitious in terms of how little room I needed. So let me go ahead and erase this. The cosine of theta is equal to adjacent over hypotenuse, which is the same thing as 1 over the secant of theta, which is the same thing as 1 over hypotenuse over adjacent, which is the same thing as adjacent over hypotenuse. There, for that line there. Bam. So it does actually work out. You can kind of prove to yourself that's the reciprocal function. Tangent of theta is the opposite over the adjacent, which is equal to 1 over the cotangent of theta, which equals 1 over adjacent over opposite, which equals opposite over adjacent. Bam. Goes back to what it's supposed to be. The opposite over adjacent is the tangent of theta. So that's how the reciprocal functions work with sine, cosine, and tangent. When you look at it with cosecant, secant, cotangent, it's basically the same thing. Cosecant is the hypotenuse over the opposite, which is the same thing as 1 over the sine of theta, which is the same thing as 1 over the opposite over the hypotenuse, which is the same thing as the hypotenuse over the opposite, which is the same thing as cosecant. All I'm really doing is just showing you how it works. Secant is 1 over the cosine, actually that's not how I was showing it, so I can't show it like that, is the hypotenuse over the adjacent, which is the same thing as 1 over the cosine of theta, which is the same thing as 1 over adjacent over hypotenuse, which is the same thing as hypotenuse over adjacent. Now many people say, is this really useful? It depends how far you want to go with math, how far you want to understand it, but it's a good complement lesson. This is adjacent over opposite, which is 1 over the tangent of theta, which is equal to 1 over opposite over adjacent, which is equal to adjacent over opposite, which equals the cotangent of theta. So, there you go. How the reciprocal functions work. Remember, sine is the reciprocal of the cosecant, secant is the reciprocal of the cosine, cotangent and tangent are reciprocals of each other. Not inverses, reciprocals. That said, have a good day for now. Goodbye.